These days, we're working towards basically getting to that general availability where we can say, hey, this is a product that we're feeling comfortable enough in its refinement that we can charge money for it. And then, that's hopefully going to provide a sustainable future for the company. And so what do I do there? You can imagine there's a lot of data being pushed around an observability platform. And Rust is a little bit more efficient than Python at handling these large volumes of data. And so I'm working on our database in the back end at the moment and making sure that that's as performant as it can be, because that's crucial for a good user experience to be able to access and retrieve and insert your data as efficiently as possible. And
that's interesting.
Yeah. And so, I'm having a lot of fun with that. We're working on providing a SQL interface to all your data, and it's about how to query it quickly, and where do we store all that data to make it quick to retrieve. There's lots of interesting Rust programming, and I'm having a lot of fun working on that.
Hello and welcome to the Pybites podcast, where we talk about Python, career, and mindset. We're your hosts. I'm Julian Sequeira.
And I am Bob Beldebos. If you're looking to improve your Python, your career, and learn the mindset for success, this is the podcast for you. Let's get started. Hello, everybody, and welcome back to the Pybites podcast. This is Bob Beldebos, and I have a very special guest with me today. With us today is David Hewitt. David, welcome to the show.
Hey there, it's a pleasure to be here. Thanks very much for inviting me.
We got the pleasure of meeting up at the Astral event at PyCon Pittsburgh, and we had a really nice chat. And I'm really excited about all the work you're doing, mainly about bridging Rust and Python. As most people know, I took on Rust for a month or so, and now life got in the way, but I got to interface with your stuff, and I think it's a plus for we're seeing Rust being used in the Python ecosystem. I think it's a very exciting thing. So I'm going to ask about all the great stuff you do. But maybe to start off, people don't know you yet. Can you give a short introduction?
So these days, I like to describe myself as trying to unite Rust and Python. I've been working on PyO3, which is an open source, primarily a Rust project, but it's an open source project that's meant to bring Python and Rust together. It's that functionality used to cross between the two languages. And then, as well as that, for a day job, I work with the team at Pydantic. So if you use the Pydantic open source package, they now have the core built in Rust. So, that was started before I joined the team, but then I've done ongoing contributions to that piece too. So, hopefully I'm bringing useful functionality to you maybe.
No, definitely. I think it's hard to find a Python developer these days that is not aware of Pydantic and is using it in some shape or form. Of course, it's very big and fast API, and we all use and love that. Yeah, so I mean, I think one of the obvious benefits of the Rust port into Python is the performance and security, but just in general, what motivates you to work on this, to bring Rust into Python?
Yeah, so I think that talking about the performance is a nice one to start with. Actually bringing aside the whole connection to Python for a moment, one of the things that I hear a lot about people who talk about Rust is I came to Rust for the performance, and then what they often go is oh, but I stayed at Rust for the reliability, or I stayed at Rust for its ease of distribution, or loads of other reasons that people have found joy in the language after they found it. And yeah, you're right that performance is probably that hook. So for me personally, I used to, a long time ago now, work professionally mixing Python and C++, actually. And that was both for performance, but also for the reliability or that a compiled language can bring. Unlike, Python with all its dynamicness, you kind of have to deal with that dynamicness in production as well, which is for better or for worse. And so what happened then is I learned Rust separately to working on PyO3. This was, again, predating that. Just as a hobbyist, I was really enjoying playing with Rust. And it was, the hook was the performance of it, but also just the pleasure of using the language. It's got some stuff that feels really familiar to Python programmers, but it's also got really, really nice modern functionality, things like options, which is we kind of have those in Python now as well in the type hit system, option, I don't know, int or whatever. But, Rust has these too. And so then it got to a point where later down the road, I was hey, I want to start contributing to the Rust ecosystem, and then realized that PyO3 already existed before I joined it. But I was I want to use this and I want it to be better, because it was still a long way from being production ready at that point. And so ever since then, I think that's really been the driving star. It's it's a thing that I want to use. And I can see it being useful for Python developers for like, yeah, the performance or for the reliability or for any one of a number of reasons. People, you can talk to them about why they're using Rust and they'll come up with different answers. And so for me, yeah, I just keep going now because it's like I still want to use it, and I get so many like feedback from people who are also they're enjoying to use it, and so it just makes sense to keep going now.
That's awesome. So it really started something like scratch my own itch. I really need this, and then you found that PyO3 was already out there. It was already in existence, and then you started to contribute it as yeah, the obvious way to do to
Yeah.
make a tool better that you really benefit from yourself. So how was that journey getting into it? Was that difficult, or how? It's I mean, the whole endeavor is there's quite some complexity involved with this, right?
Yeah, so I was lucky again that I'd been doing in the professional work before that, the mixing of Python and C++. So it kind of gave me like an idea of how like mixing Python and a compiled language works. But, then there's a whole different like set of problems to solve when mixing Rust with Python than there is with C++ with Python. And so like, how did I get started? I was kind of just like, I had some time to get into the open source project and started just contributing to like small issues at the beginning. It was kind of, people were asking questions about how to use it or some functionality which wasn't working, maybe a bug report, or maybe it was like more complicated things like, hey, I'm trying to make a Blender plugin for Blender, I think has like a Python API, but you can do Rust pieces. Well, they wanted to compile Rust into their Python Blender plugin. And I was like, how on earth is this supposed to work? And just like tinkering around and trying to figure out what people were using. It's like the constant question was like, hey, how can I make this better so that people don't find it so hard next time? And like it taught me a lot about all of this integration. And like I wouldn't have said that I knew everything going into it. I've learned so much over those like 5 years now. And so yeah, it's just like an incremental start from the really small, like, hey, someone has a real need here. And then, it's sort of got more and more high level and broad picture as I've gone along.
Yeah, that's very similar to what Marcelo shared here on the podcast, right? Like you just have to dive in. You don't know everything, but if you just work from the issues and troubleshoot and solve problems, or even just do small contributions like documentation, but mostly like working backwards from the bug reports, then you just organically grow into it, right?
I actually have some like, or since like, first features that I actually contributed to PyO3, interestingly, I've now since ripped out again for various reasons, whether they were poorly designed or like had subtle bugs in them or stuff like this. And so like, even that first stuff that I did, like it solved some user needs at the time, but we learned like why that was a mistake later. So I think that was an interesting part of the journey to realize that, everyone's got to learn, and you go from the beginning. You don't need to worry necessarily about getting it right first time, because hopefully there's someone else to also guide you and give you feedback to make it better in the future.
That's a good point. And we see that often with our coaching as well in the program where people build applications. Like you don't have all the answers, right? So you just have to start and push code out there, and you might get it wrong, but then you fix it later. But what happens a lot in our space is that people get into that tutorial paralysis or paralysis by analysis, but you have to take those steps, right? Even if you might be wrong, but it's all fixable.
Yeah, absolutely. And like that's actually a good touching point on Rust again, actually, is that compared to a language like C++, I find that with Rust, I feel more confident to try things. And the Rust compiler, I guess you've experienced this yourself, it's very pedantic. It will tell you, hey, this is wrong, or it gives you quite good feedback as well on what you might try instead. But I feel a lot more confident trying experiments in Rust, knowing that I'm not going to create massive security vulnerabilities just from typing 3 lines of code or whatever, which is a refreshing feeling.
Yeah, I'm going to butcher this, but in one of the Manning books, I think the Rust compiler was compared with this very critical partner or spouse that's going to criticize you a lot before you go out of the door, and you will hate it. But once you get out of the door, you actually will look good because of all that. It's kind of a weird comparison, but yeah, that was my experience as well, especially coming from Python. Like the compiler is so strict and pedantic, what it seems, but then for your own good, right? That later down the road things don't blow up, because that unfortunately can happen with Python. It's so permissive, but then at runtime you might find surprises. Yeah. Okay. So PyO3, that has been pivotal in the Rust in the Pydantic core rewrite, right? That's actually the tool that allows Rust to come into the core of Pydantic, isn't it?
Yeah, exactly. So Samuel started, Samuel being the like founder of Pydantic, who like did all of the early work on it, including the beginnings of the Rust integration. I think it was like 2022 or something. He started doing this. It wasn't actually the first time that he'd used PyO3 to like some Python packages. He'd done one called like rtoml and another one called watch files previously. But so he took his experience from building Pydantic v1 and thought, how can I like extract the core logic of that and turn it into a Rust program instead, so that that really heavy lifting that Pydantic's doing, like, you know, taking your JSON data or whatever and turning it into useful Python types is like done in Rust, which Rust is very, very good at, and trying to just like bring the speed up and the energy efficiency up and all of those good things about having a Rust core to the package. And so, yes, Samuel was basically building it on top of PyO3. And, you know, at the time I got to know him because he was just reporting bugs on the PyO3 issue tracker or saying, hey, like, how do I do this? Because the documentation is not helpful. And, you know, we incrementally fixed some pieces. And over time, the Pydantic core, as we call it, built up in Rust. And yeah, about May 2023. So it's been a year and a bit now. It released for V2, which brought the speed ups. And we've been working on it since as well.
Yeah, massive. And also all the rippling effect of that then making fast API faster. And
yeah.
Yeah, Samuel was on the podcast talking about this as well. So yeah, super, super exciting. And are rough and polars then also using PyO3? Is that?
Yes. So in different ways. So Polars is using PyO3 in the kind of way that we're already talking about here, where Polars is a Rust app or library where you import it and you use PyO3 to like wrap the Rust core, which Polars has, to make a Python API, which, you know, if you're a Python user using Polars, that's what you experience. You experience the PyO3 wrapped API that Polars is providing. Rough is a little bit different, like because that is just a Rust program that's like parsing Python source code and doing like linting or analysis based on that. It doesn't actually use PyO3 itself, which is because PyO3 is more about like talking to the Python interpreter. And in Rust's case, there actually isn't a Python interpreter running. It's just a Rust program. But it still uses our packaging tools to like take that Rust code, compile it, put it into a pip installable package so that you can just do pip install rough. So it's like it benefits from the PyO3 ecosystem, if you like, but not PyO3 directly.
Yeah, that's good. That's good to know. Like the others are more like libraries, and this is more like a tool.
Yeah.
But yeah, it's good to know that both still leverage PyO3. Yeah.
Mm-hmm.
And is there also what? So we talk about a lot about getting Rust into Python, but the tool also supports bringing Python into Rust. But I was not sure what the use case for that is.
Yes, the use case for this is more like you have a Rust program, and like an example of this might be like a video game is quite a good example where like, you know, the thing is in Rust primarily for performance, but you want to provide some like flexible extension like language, like a scripting API or something like that. And so then you could embed a Python interpreter using PyO3 and make calls from Rust into your embedded Python interpreter where you can let users provide like plugin scripts if you like. And so that would be the model there. So a video game is like the most natural fit. You could imagine like if someone built a text editor built in Rust, then maybe they could use PyO3 to provide a scripting interface for it, or, you know, something like that.
Yeah. Okay. Makes sense. Cool. So what are you working on at Pydantic these days?
Yeah. So I split my time. Pydantic is now a commercial company, and I think Samuel's actually been on your podcast before to talk about like a bit of that commercial history. So I won't really go into it here. But so we have, as a startup, like we obviously need to like keep putting bread on the table, if it were like. And so the primary focus for us at the moment is getting our first product to general availability. It's a product called Pydantic Logfire, and it's an observability platform. I think Samuel's talked about it, so I won't go into much more detail here.
He was on the podcast the day or the week before launch, or when it just launched, and we had even a quick demo on the podcast. So that was cool.
Perfect. Yeah. So these days we're working towards like basically getting to that general availability where we can say, hey, this is a product that we're feeling, you know, comfortable enough in its refinement that we can charge money for it. And then, you know, that's hopefully going to provide a sustainable future for the company. And so what do I do there? You can imagine there's a lot of data being pushed around an observability platform. And Rust is a little bit more efficient than Python at handling these large volumes of data. And so I'm working on our database in the back end at the moment and making sure that that's as performant as it can be, because that's crucial for a good user experience to be able to access and retrieve, well, and insert your data as efficiently as possible. And
that's interesting.
Yeah. And so, yeah, I'm having a lot of fun with that. Like, we're working on providing a SQL interface to all your data, and it's about how to query it quickly, and where do we store all that data to make it quick to retrieve. There's lots of interesting Rust programming, and I'm having a lot of fun working on that. But then I do a little bit on Pydantic on the open source stuff. It's a bit less time for that at the moment because, as I say, we're focusing on like getting to availability for Pydantic Logfire. But I still do read reviews of user contributions, and I'm kind of thinking in the background about our next work that we want to do on the core Pydantic Rust Pydantic core to make it even more efficient and easy to use in the future.
No, that's fascinating. Yeah. Talking about the user experience, what I noticed as a new Rust user, how friendly PyO3 is, because I remember I sent you that little mind map I made, and it was very easy to wrap my head around and to write a little bit of Rust and then integrate it, and turn it into an importable library or function. So, and that I think is also in part due to the maturin wrapper, which takes care of the whole packaging aspect. But yeah, how do you think about the ergonomics of a library like this, right? Like, or Python users being new to Rust, how do you think about design to make this accessible? Because again, kudos, it really is accessible.
That's really pleasing to hear. I think that's personally, like, I guess one of my guiding stars of what I want to do with PyO3. Like, it's important for performance to be good, but it's also like equally as important, or maybe in some cases even more important, that the user experience of someone writing these bindings it works as they expect. And so I guess, like, if we want to talk about the maturin wrapper in particular as like a nice example of this, like back a long time ago, when I was mixing Python and C++ and trying to figure out how do I compile a C++ library and then turn it into something that's importable from Python and all of this, like, it was a really long, hard journey to figure out how to get the C++ compiler to do what I wanted. And how am I supposed to set this up so that Python can import it properly? And then, oh no, the first thing that happens when I compile it is I get a segmentation fault and it all crashed. And it's like, well, why? And then it's like I sit down with a C++ debugger and try and figure out, okay, what on earth have I got wrong here? And one thing that I found just as a Rust hobbyist is that your debugging experience tends to be a lot nicer because that compiler is so strict. And it's about applying that whole ethos to everything. Let's just make the obvious thing feel nice and nudge users onto the obvious path and make it all just flow well. And so, yeah, maturin, the idea is that it should be just as easy as pip install my Rust code, and it can go away and do the hard thinking for you, get all the, the compiler options right, or all of that kind of complicated stuff. And then in combination with PyO3 being the actual code that you've written, it should just work. And it's that's a really important thing to me. I actually the first experience I actually had using PyO3 as a user before I was a contributor to it. I was working on a personal project with my father, and it was my dad's not a computer programmer, but he's a hobbyist. He's got a few personal projects that he does to look after some data for some volunteer groups that he's related to. And I was like, hey, you could process this data faster with a little bit of Rust, because he was reaching challenges of doing it all in Python. And so at that time, I wasn't contributing to PyO3. I was looking through the PyO3 user guide and okay, how do I install this? How do I get this working? And I had a really hard time, just as I had doing it with Python and C++. And so, that kind of experience, I was my dad was then just not going to buy into it. He was like, this is way too complicated for me to understand. And ever since then, that was a lesson for me, right? That if I want to tell other people, hey, you should give this a go, then it has to be straightforward and easy.
Wow. So your dad had an influence on this, on your programming journey. That's awesome.
I'm not sure if he knows that directly, but it definitely stuck with me, that experience of that was just too hard. Whereas I think if I went back to him now and said hey, Rust is ready for you to use this in your application, I think he might be convinced this time. He actually does more stuff with TypeScript and web front ends at the moment than he does with the Python data processing, but maybe he can come back to that in the future. I think he'd be game to give it a try now.
That's awesome. So there's inherent complexity with all this, and as you described, was a long, arduous journey. How do you manage complexity? Like, what is the mindset you adopt? The problem-solving techniques? Because again, this stuff is just complex. I mean, I will link your PyCon 24 talk below. You also did another interview on a podcast. And yeah, the the complexity there is large. So I just want to, from a mindset perspective, how do you tackle that? Do you have certain techniques, things that just work for you to manage complexity?
Yeah, it's a great question. So some people are really good at like, self-introspection and having like measured approaches, or like, hey, I know that if I want to solve a problem like this, I need to go like have a coffee and like, write down the problem and like map it out or whatever first, or like, there's different ways that people like to think. What I find is like, I guess I start by trying to think like what do I actually want people to experience here? Like what's the nice user end result? And like sometimes it's, oh, this needs to be faster, or quite often the nice thing about working on a library like PyO3 is that people have like an obvious expectation of like, you have a Rust string, you want it to become a Python string when you like pass it across the boundary. And it's like, okay, how do we make that actually happen? And then it's like, I tend to be a bit random of like, I'm just reading like material when I've got a chance to like understand that problem. And it might be then like, I'm in the shower or like on a walk or whatever. It's like in the back of my head, it's just like going. Sometimes my poor family can like get really annoyed actually, because, like if there's a problem that I'm thinking about like that, it kind of consumes me a little bit. And then once I'm finished thinking, I'm really tired. And it's like, I almost can't stop myself sometimes when I'm in that kind of problem. Like I just go too deep. And it's been a problem for like 20 years or something, it's just like, that's how I think sometimes. But so
That's
yeah,
a blessing and a curse we have as programmers, right? Like you cannot detach sometimes.
yeah, I remember like talking to my family about that actually, like when I was a teenager, before I ever went into like software as a professional. And I remember telling them like I shouldn't go into software as a professional, because like when I do code, like as a teenager, I did a little bit of hobbyist coding just to play. I never really produced anything interesting, but I loved learning about it. And like every time I did it, I had this exact same problem. Like as a beginner programmer, I couldn't stop myself. Here I still am consuming all my time thinking about it. My wife is very, very patient, and I'm very grateful to her for that.
Yeah, we have to thank the wise
Yes.
partners in this. Was there an alternative?
And like every time I did it, I had this exact same problem. Like as a beginner programmer, my mind just got consumed by like trying to understand this like little thing that I was trying to do. And I was like, to my family, I was like, I shouldn't be a programmer because it just makes me too tired and it consumes too much of my time. And like 20 years later, it's like, well, the realistic options when I was choosing what to study was between computer science and physics. And someone told me from their family who was a computer scientist that if like, yes, there are important parts of a computer science degree, but it's probably easier to like become a computer scientist without a computer science degree than it is to become a physicist, without a physics degree. And so I actually ended up doing a physics degree kind of based on that kind of advice. But yeah, at the end of the degree, then the cooling of software basically pulled me away from it pretty much straight away.
Yeah. Gotcha. I wanted to talk about Rust growth. Anything else you wanted to say on the complexity part? So I hear a lot of like, yeah, the tenacity of cannot let loose. You cannot detach from a problem, which is kind of what we have as programmers. But then also the real breakthroughs then come actually when you are doing something else, right? Shower, walks, whatever. So
Yeah. Oh, well, oftentimes I guess if I was to break it down into like a process, it's like I need to know what the end result I want is, because like without trying to like find the end result, then I would just get lost in like this sea of like thinking about it. But once I've got that, then it's about like I kind of asking myself like, okay, what bit do I not understand now, or like what bit do I, do is not working, and like why is it not working, or why don't I understand it? And like, it's about going to some cases it's reading C Python documentation, or like other times it's actually looking inside the Python interpreter, or looking at like articles on the Rust language if it's a Rust design question, like, reading on whatever kind of stuff. But I'm always remembering like what's that like end user experience that I want to get to in the end, so that like I don't get too lost in the depth. But there is often a lot of depth, and you just got to go there.
that's a great piece of advice. Like in our programs as well, we do mind mapping, but sometimes for people that doesn't really work, and then we always ask about do the ideal end user result exercise. So imagine the end user of your software comes in. How does it look? What can the user do? What their optimal experience, right? And when you work back from that scenario, then it becomes much clearer and you can be hyper focused, right?
Yeah, definitely. I like to
Cool.
say that if people have built software in PyO3, that people using that software hopefully shouldn't notice that the code's built in Rust. It should be invisible to them is like a goal. I think in practice, there's some bits that don't quite work like that, but that's the goal.
Yeah, with my short exposure and experience, I can definitely attest that that's the case. So 3 more questions. Rust growth. So yeah, we see. I think you spotted a trend, right? That the Rust related packages, and correct me if I'm wrong, the Rust related packages was doubling every year on PyPI. Was that the
Yes,
metric?
which was extremely exciting to see. So to start a bit more specifically, I looked at upload numbers to PyPI for different packages which contained Rust, like how many different packages in a given month were being uploaded which contained Rust code. And I just April, like every year, 2020, 2021, 2022, 2023, 2024. And like it goes in a pattern where like every April, the number of different packages that have been uploaded with Rust code in the next April has doubled. So it like went from like 12 to 25 to 50 to 100, like maybe, I can't remember the exact trend, but it was like that sort of pattern. And it was just getting twice as big every year. And, I think C and C++ for a sense of scale is something more like maybe it was like 1,000 or 1,500 or something like that. So, Rust is still quite a bit smaller, but, every year it doubles and it's becoming a bit closer to a comparable size. Will that trend continue? I don't know, but it's exciting to see for sure.
Yeah, you presented that table in your PyCon talk as well, I think, and
Yeah.
I think C++ was more linear, but then there were just a lot of packages already around there, so the nominal number is bigger, but with an exponential almost trend, and that might catch up very quickly, right? So, but yeah, we don't know, but it's kind of a signal that not Rust is taking over, but it's definitely just being used increasingly also in the Python space, right? So. I want to ask for the audience, mainly consisting of Pythonistas, should they learn Rust? And if so, why? Or is it more a matter of partner up with some great Rust programmers and learn more about the integration? What would you recommend?
So, that's an interesting question. I think I would say it like this. Like, I don't think as a Pythonista, you should feel like you have to learn Rust because, Python is like an incredibly useful language. And it's because of its ability to tap into not just Rust, but like C, C++, and like Fortran. And I think you could even mix like Go or other languages if you wanted into your Python code. But like, you don't have to do that yourself. It's done through like other integrations and the fact that Python can do this. And so Rust is just another one of those tools at that layer, if you like, and you don't need to know it. You shouldn't feel like excluded from being in Python because like Rust is also becoming a presence on the scene. But for those people that have an interest in doing so, then I think that there absolutely can be like valuable insights to learn from learning a language like Rust. Like it has quite a novel take on a few different ideas. Like it cuts away like object-oriented inheritance. I don't know if you noticed that in the time that you were working with Rust, but it also introduces new concepts like lifetimes or traits. I mean, traits come from, I think, other languages, more like Haskell, I think, has a similar idea maybe. And they feel a bit like Python's protocols, sorry, not prototypes, protocols or abstract-based classes, but they work a little bit differently. Or even things like Rust has enums as a language thing, and it's kind of hard to explain those without just going and trying them, but I just love those as a concept. And so for the Pythonistas that want to go a little bit deeper and like want to have a try at like tapping into, if you've got like a problem where the performance is not good enough, as I say, like that's often the first hook for why you might try Rust out. Sometimes it's just for intellectual curiosity. Then yeah, it can definitely be a super valuable learning experience, and it might unlock like a next level of what you can do with your own Python. But it's certainly not an essential.
Yeah, it definitely like I did it for a month, and then life got in the way in summer and all that. Also, I was just pressuring myself, and it's like, no, let's take this as a long-term journey. But it definitely expanded my mind. You just come way more wary of typing, and so you start to be way more fanatical about type-ins in Python because you see the benefit in Rust, right, where it's required. The compiler, the tooling is amazing. Cargo, absolutely fantastic. But also, yeah, exception handling, for example, with match case, and there's definitely a lot of elegant things there, but it's also still a quite steep learning curve, right? You have that whole, so there's no garbage collector, so you have the whole thing with lifetimes and borrowing, and that's really mind blowing, right? That's I mean, conceptually, I do get it, but then to actually use it, that's quite difficult, right?
Yeah. You have this really famous like Rust saying called fighting the borrow checker, right? Where it's basically, it's again like going back to that, like the compiler's like your strict BIOS that's telling you no all the time. Like a lot of the time what it's telling you no is because you've got lifetime rules wrong. And it takes a lot of like trial and error, I find more or less everyone finds as a Rust learner to like understand the rules. But like once you get there, then it's another useful tool to like have in the back of your mind.
Yeah. It's daunting, but it's rewarding, and yeah. But on the other hand, for me it was also more like an intellectual thing, because after a month I concluded like what I actually have done is mostly scripting, which I could have done in Python. I didn't even touch the system programming side. So yeah, I like your advice. Like if there's something performance sensitive, then it makes most sense. But to go rewrite the Pybyte search command line tool, that was a nice exercise, but that was fast enough in Python, right? So it was, again, more like an intellectual thing.
Yes, that makes total sense.
In just 12 weeks, Pybites elevates you from Python coder to confident developer. Build real-world applications, enhance your portfolio, earn a professional certification showcasing tangible skills, and unlock career opportunities you might not even imagine right now. Apply now at pybit.ds/PDM.
But yeah, if people want to take it up, in terms of learning resources, how would you, because as we established, it is a steep learning curve, especially if you have done mostly dynamic languages and not compiled languages, like my experience was. Do you have any advice how to best get started?
Yeah, I think, well, it depends a bit on like your preferred style of learning, right? Because some people I think like to structure learning by just doing something. And some people like to structure something by more like reading a course or reading a book or whatever. And like I'm not a great reader actually recently. I used to be a reader when I was much younger, but these days I don't find time for it. So I'm a bit out of touch with what the good books are. I think on good books to read. I hear a lot of good things about the Rustlings course of exercises. It's like practical exercises where you can try incrementally. They kind of like up the complexity and ask you to do more complicated things with the language. And I think that is still being maintained and like actively improved. It's meant to be like a nice first experience for people wanting to learn Rust in isolation. If you're a learning by doing type, then I guess that's sort of like a halfway. That might work for you, but you might also just prefer to have a personal project where you're like, hey, I guess for you that was writing the Pybyte search engine as a Rust program instead, right? There was a very concrete project and you could kind of chip away at that. And so, I always am mindful as well that for some users, PyO3 is going to be the first time they try Rust. And so, like, the PyO3 user guide, like, in the back of my mind, I'm always like, does this make sense to a Python reader? And, like, it's hard to really achieve that. And especially, like, I'm tainted at this point. I've been thinking of Rust for 4.5 years. So it's hard for me to ask the question, like, if I knew nothing about Rust, does this make sense to me? But I do try and like imagine that if someone was a Python user and they want to just like, pip install maturin, start a new project, there's a maturin new command that you can do to do that. You get your like Python template that you can then start editing the Rust code in. I want it to kind of like make sense, hopefully. And, that can be a way for people to learn by kind of like play and experimentation. Or maybe they have a real performance problem to solve, as we say.
Yeah, no, those are great tips. I definitely, as Pybites, right, there's like, build something before you, so you'll and the official Rust programming book, which is free online, is good. It's also pretty in depth, so just read it and knowingly that you won't get it all at first. And the Rust links are great. I really like how they have set it up. You just clone a repo, and then there's like that watchdog thing going, so as you type the code, it just runs the tests in parallel. So it's a really, it's like 100 mini exercises, and it's really good.
I think they recently rewrote it to have like a terminal view or something as well. I should really try it out because I'm recommending it to people all the time. And like, I haven't looked at it for a long time myself, but I hear it's really good. Everyone who I recommend it to is like, that was good fun.
And again, the compiler shout out, because with AI tools, you have that danger of hallucination and stuff. But that won't get past the compiler. So
Yes, that's totally true.
Yeah. Cool. So Azure, you said you were so busy and not reading that much. I won't do the book question, but I saw in your bio that you're streaming PyO3 stuff to YouTube. So I did want to ask about that.
Yeah. So I have actually had a little gap at the moment, but so I started it earlier in the year, and I found it was a really super valuable thing. Like basically every Friday morning, I managed to keep it up for I think something like 2.5, 3 months before family life got in the way. We had like some sickness in the family, and then I had a baby and stuff. So it's been a long break. But just talking about either side, I'm hoping to get back to it in September. I've got like buy-in from my family that things are calm enough with the new baby's arrival and all of that I can return to it. So that's the current plan. But yeah, so every Friday morning, I was basically thinking about something that I was working on PyO3 that week, which was like a meaty enough problem that it was interesting to kind of like talk about and try and solve, like ideally with the community, like having a chance to have a little bit of input, but also just seeing me like think about it myself. And I thought that this would be a good way to show how PyO3 is working for those people that really want to go into the depth and like see what it's like to try and solve some of those like complex problems, as you say. And like it was a really interesting journey for me. We did some like different topics. Like we did some stuff about how Rust is interacting with CPython, the interpreter, and like the FFI that goes on there. And we actually had some of the CPython core developers join and watch the stream and like give me a lot of feedback as we were doing that stream, which was super valuable. And I think actually like we built a bit of a connection since, and that's helping like improve the quality of both what CPython API is delivering, but also like what we can do in PyO3 as a result of what we learned from like seeing what each other wanted from that. But also like I remember one stream where I had this idea for like, I want to like create a nice error message basically for like if you did something wrong with a particular case in PyO3, like you say the Rust compiler is strict and like gives you errors, and like I want that same experience to go on to like if you're writing bad or like incorrect PyO3 code, you should get helpful error messages out too. And I had like an idea of how it might work, and I spent like the first half of the stream, maybe 45 minutes to an hour, talking about the problem and like how I thought it could work. And then we went and started trying to implement it, and the reality was much more complex than the idea I had. I knew I had like a relatively hard cutoff for family related reasons. And so it's just like, as we get closer and closer to the end of the stream, I'm just more and more like just typing furiously, like, oh, come on, we can get this to work. I'm sorry, everybody. This is like probably less interesting for you now as I'm like just typing and typing and typing. But, that was kind of like, that's the reality sometimes of what it's like when I'm trying to work on these problems. And so maybe people found that interesting too. I don't know. But yeah, I had a lot of good fun with those. And I think it actually helped welcome new contributors into PyO3 by like showing them what was going on. And so I'm looking forward to getting back to that again soon.
Yeah, kudos on that, because it takes a lot of guts to actually do that. To go on there and keep it raw, and things might not come to closure and you might fail and all that. But I did learn over the years that that's actually the part that people like the most. They don't seek perfect crafted solution videos. I mean, they do, but that's another type of YouTube video. But actually the raw process and seeing you in the guts of it and failing and the thought process. And then if you talk through the thought process, that's what people really like. Plus, it's kind of the expectation of a live stream, right? You're going in there and you're going to see something that's not like pre-edited. So, but yeah, it takes a lot of guts.
Yeah, absolutely. If I was making a regular commitment like that, I wanted to like do something to broadcast to the community, but because, as I say, like I'm already so time poor, I was like, it has to somehow fit with actually like what I'm doing on the PyO3 maintenance. And so being raw was the only real option, but it was good fun. I look forward to going back to it. As I say, the plan is we've got Python 3.13's pre-threading support coming up. And there's more that PyO3 needs to do to support that well. And so I want to really get into the problems related to that and like think about those on stream. I think that would be a really fun like series that we could have there.
That's awesome. I might join one day.
Yeah.
But also like the lesson of like we get into our silos, but we have to not only do the work, but actively putting it out there, right? So it's really nice to hear that builds up connections and that.
Yeah, that was a lesson that like was really like instructive to learn, I guess, because for a long time I was working on PyO3, and maybe it was also because like it was earlier days for PyO3, the adoption was smaller or whatever, and it was like more in that silo, as you say. But then to go out and like realize that actually there's enough people using this that this needs to have like a bigger community and more connections was like was almost like a light bulb moment for me. It's like, I need to be trying to do this as well as just writing code.
Yeah. Awesome. Yeah, the balance of coding and well, I wouldn't call it marketing, but just outreach,
Yeah, it's about like, building that network so that everyone can help each other. Because
Networking.
we're all in our little silos, then it's no good for anybody. Like, exchange of ideas helps us all make it better.
Yeah, exactly. Well, cool. Well, thanks for the great work you're doing there, getting Rust into Python, and very interesting for us, Pythonistas. And thanks for sharing all the great insight. Anything else? A final shout out? Or something you couldn't tell with the questions? So you want to share?
I guess that's kind of it. Like, there's a call out. It's like, if you want to, I guess I'd want to talk about like getting started in open source. I thought was like an interesting thing for me. I kind of mentioned it already, like how I just started by like doing issues and like picking up the small pieces and even contributing features that then I've ripped out since. And like people have asked me since, like, how did you get started in open source? And it is kind of that, like, don't be afraid to make the first step, because, over time you'll learn like more and more, and then you'll find it easier and easier to keep going. And, you don't have to get it right first time. And like just a support and a bit of be brave and make that jump is something that I'd like to shout out for.
Yeah, I'm glad you mentioned it, because it can be very intimidating. It seems like everybody is scrutinizing your code, or there's a lot of critique, but people are actually really grateful to get the help, right? Because often there's just more work than resources on those projects.
Yeah.
But it's also a gradual exposure of things. Like the first time it's hard, and the second time, third time, the nth time it just becomes normal. It normalizes, right?
Yeah, absolutely.
Yeah. Fantastic. Well, again, thanks for joining us today, David. Thanks for all the work, and we'll be in touch.
It's been a pleasure. Thanks for having me on.
All right, thanks.
We hope you enjoyed this episode. To hear more from us, go to Pybites/friends. That is pybit.es/friends, and receive a free gift just for being a friend of the show.
And to join our thriving community of Python programmers, go to Pybites/community. That's pybit.es/community. We hope to see you there and catch you in the next episode.